So in this video we're going to look at looking at a basic introduction to thermochemistry, and we're also going to look at endothermic and exothermic reactions. Okay, so thermochemistry is based on a number of both thematic and chemical concepts. Okay? When we talk about thermochemistry thematically, we talk about the chemical basis of combustion, what makes a good fuel, the strengths and weaknesses of existing fuels, and the effects of combustion on the greenhouse effect. Okay? When we talk about thermochemistry chemically, we talk about energy, we talk about enthalpy, we talk about Hess's law, about heat capacity, and energy level diagrams. We will also have to work through calculations in terms of calculating the heat of reactions and thermodynamic cycles. Okay. It's important to note that whenever we do any calculations and whenever we talk about energy at all, it's always going to be in terms of joules, because that's a unit we're going to use for energy. Okay. So all molecules have a particular internal energy. Okay. This internal energy comes from kinetic energy that the molecules have produced by their movement, the vibrational and rotational energy that they have, as well as their bond energy. Okay? It is essential that we're able to appreciate this, as it becomes very important for later concepts. We're now going to talk about the two different types of reactions that are possible. Okay, so this is really the basis of thermochemistry, the fact that we have two types of reactions that are possible. Okay? These two types are reactions that produce heat, so exothermic reactions, or reactions that require heat, and these are known as endothermic reactions. Okay? Exothermic reactions result in a decrease in the internal energy of molecules, as energy in the form of heat is released into the surroundings. On the other hand, endothermic reactions result in an increase in the internal energy of molecules, as energy in the form of heat is absorbed from the surroundings. The main change in internal energy in a chemical reaction is associated with bond energies. So we can actually look at an energy diagram in order to understand this. Okay. So if I was to draw an energy diagram for an endothermic reaction, if this we have is energy, the internal energy of the molecules, we have the reactants here, and we have the product here. Okay, so as you can see, there's been an increase in the energy. Okay, this is endothermic, and this tells us that the change in internal energy is greater than zero, so it's a positive change in internal energy. Okay, if we were, however, to look at an exothermic reaction, you'd find that the reactants would be higher in energy than the products. Okay, so we have a decrease in energy. Okay, so this is our exothermic reaction, and our change in internal energy is less than zero. Okay, because there's decrease in internal energy. Okay. We can actually measure the internal energy change using what we call a device we call a bomb calorimeter. This is a device that's thermally insulated from the rest of the universe and is able to measure the change in heat of the surroundings when a combustion reaction occurs. Okay, so we'll look more into bomb calorimeters in a later video. Okay, so, but that's, now I've given you, I guess, a general introduction to thermochemistry and to the two, I guess, the basis of thermochemistry, which is the two types of reactions that are possible, our endothermic reactions and our exothermic reactions. Okay, so that brings us to the end of this video. Thank you.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.